All right, Calculus BC students, here comes what is going to be my final video to help you guys get ready for the Calculus BC exam. This question is an advanced integration technique question. I unfortunately did not keep track of the source, and right now I'm not going to worry about that too terribly much. But it comes from a BC Calculus exam, a recent Calculus BC exam. This question is calculator inactive, and this question has kicked my butt on at least 3 different occasions. I tried working this out last year with my BC students at Southwest, got myself all turned around, tried working through this problem on my own earlier this week. I was pretty successful, but I only got 6 out of the 9 points, and that is unusual for me. Really love this question. I hope you find it enjoyable as well. This is a tough question, but let's see what we can do. And remember, calculator inactive. And I've got my scoring guide right here, just in case. Okay, f of x equals x times e to the negative x squared for all real numbers x. At what value of x does f attain its absolute maximum value? Now, what you might be expecting is that, well, usually when we do an absolute max or an absolute min kind of question, they give us endpoints. That would make this question easier. This already is going to be a challenge. So, when I go looking for an absolute max, right, we look for something that we call the candidate. The candidate is your relative max. Specifically, it's where f prime will make a change from positive to negative. So in order to do this, you're going to have to find f prime. Now, your function is x e to the negative x squared. I would assume for just about everybody watching this video in a Calculus BC class, the derivative not too bad. You take the derivative of the first part, which is 1. You leave the next part alone. Plus, now you leave the first part alone, times the derivative of e to the negative x squared. Well, that's e to the negative x squared times the derivative of negative x squared because of your chain rule. Well, that's your derivative. You're trying to figure out where the derivative changes from positive to negative, so we're going to set the derivative equal to 0. Holy moly, look at that. You've got to figure out where this equation is equal to 0, and you don't get a graphing calculator. Well, what could you do? You could clean this up a little bit. For example, 1 times e to the negative x squared is e to the negative x squared. X times negative 2x is negative 2x squared, e to the negative x squared. Where's that equal to 0? If you're an astute algebra student, you might notice I've got e to the negative x squared and e to the negative x squared. So why don't I factor that out? And it leaves me 1 minus 2x squared. I'm going to set that equal to 0. If e to the negative x squared times 1 minus 2x squared equals 0, then it means that e to the negative x squared equals 0, or 1 minus 2x squared is equal to 0. Now this guy on the right's not too bad. Negative 2x squared equals negative 1. I could divide by negative 2. X squared is positive 1/2. Sorry about that. So x is plus or minus the square root of 1/2. If you want to rationalize the denominator, feel free. You're going to get plus or minus the square root of 2 over 2. Now let's come over here. E to the negative x squared is equal to 0. When is e to a power equal to 0? Never. Never, ever, 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 ever is e to the negative x squared equal to 0. So you've got 2 possible values on the number line that I'm interested in. What I'm going to do is I'm going to build my number line for f prime. Here's x equals negative square root of 2 over 2. Here's x equals positive square root of 2 over 2. At both of these places, the derivative is equal to 0. I'm now going to select values of x in each of these 3 intervals. Let's pick a nice easy one, like for example, x equals 0 in this middle interval. e to the 0 power is 1, positive 1. 1 minus 2 times 0 squared is positive, so I'm getting positive values in this interval. To the right of x equals square root of 2 over 2, maybe you want to try like 1. E to any power is positive. 1 minus 2 times 1 squared is negative, so we're negative over there. To the left of negative square root of 2 over 2, you could try x equals negative 1. E to the negative of negative 1 squared, well, that's still a positive value. 1 minus 2 times negative 1 squared, that's a negative value. And so what are we looking for? We're looking for a relative max. A relative max occurs when f prime changes from positive to negative, so that must be here at x equals the square root of 2 over 2. Now, initially, I jumped too quickly, and I said, oh, I have a relative max, so this must be the absolute max, but you actually can't say that for sure. You can't say that with confidence, because what do we know? We know that the graph actually has 2 turning points. And this argument of a relative max being an absolute max or a relative min being an absolute min is something that you can only do if you have one time where the function changes from increasing to decreasing or decreasing to increasing. We can't use that argument here, and honestly that was, for me, place number 1 where I got stuck. And I looked at the College Board scoring rubric. I'll out myself there. And here is what I found there. Here's their recommendation. Their recommendation involved going back to the original function. And think about the original function for a little bit. The original function is, off the page, my bad, x times e to the negative x squared. Now, I understand without a calculator you don't know what this looks like. But if x is greater than 0, you've got a positive number times a positive number. F of x is positive. If x is less than 0, we have a negative here. E to any power is positive, so f of x must be less than 0. And if x equals 0, then f of x equals 0. Well, let's take that information and think about that for a bit. What do we know? When I sketch my graph, the graph has to pass through the origin. And then what has to happen is my function for all values of x greater than 0 is positive, so I'm not going to have any values down here. For values of x less than 0, f of x is negative. I won't have any values up here. Now add on your derivative information. For me, it's slightly off the screen. If x equals square root of 2 over 2, well, from negative square root of 2 over 2, here's negative square root of 2 over 2, to x equals positive square root of 2 over 2, what I know is before I get to x equals negative square root of 2 over 2, my function is decreasing. But I have to be decreasing in a way that I don't make it up into the second quadrant. So my graph is probably going to look something like that. At x equals negative square root of 2 over 2, I start to increase, but I have to increase and pass through the origin. From 0 to square root of 2 over 2, I continue to increase. And from x equals square root of 2 over 2 on to forever, my graph decreases and will never get down into this quadrant. That is a tough graph. But now that I've got the graph in front of me, I hope you're convinced where the absolute maximum occurs. It's going to have to be here at the relative max. The problem, though, is you can't justify it simply based on the graph. So what you're going to have to do is do something like this. For x greater than 0, f of x is positive. For x less than 0, f of x is negative. For x equals 0, f of x equals 0. So the absolute max must occur for some value of x greater than 0. Because f prime changes positive to negative at x equals square root of 2 over 2, and there are no other changes, the absolute max must occur at x equals square root of 2 over 2. To be honest, that is just, thought that was mean. I did not think about this as my justification, and I have been teaching calculus for a long time. So let me tell you where the points came from. Way back in the beginning, remember when we found the derivative? That was 2 points. So I bet that's 2 points that you locked in pretty much right away. When you made the decision to set the derivative equal to 0, that got you another point. When we solved and got x equals positive square root of 2 over 2 and negative square root of 2 over 2, that got you a 4th point. And then all this stuff down here was the last point. So part A was worth 5 points. And I would bet any amount of money that the year that this showed up on the BC exam, that part A was not a high scoring question. I bet a lot of students earned the first 3 points, maybe even the first 4 points. I would be hard pressed to believe that lots of students came up with this last justification. I bet some kids did, but I don't think it was a lot. Maybe that's just my trying to make myself feel good. Okay, part B. Part B, let me get down in between the lines. Find an antiderivative of f. An antiderivative just means integrate x e to the negative x squared with respect to x. Now, how are you going to integrate something like this? You've got some options, but for the sake of time, I'm going to jump right to the way that I would go and do this. I see that negative x squared in the exponent. If I let u equal negative x squared, I can then take the derivative with respect to x and get negative 2x. Multiplying, we get du equals negative 2x. So dx is du over negative 2x. Do your replacement, you get x times e to the u, du over negative 2x. The x here and the x down here can cancel out. The negative 2 you're dividing by, I can factor that out as a negative 1/2. You're integrating e to the u with respect to u, so that is going to be negative 1/2 e to the u plus Charlie, or negative 1/2 e to the negative x squared plus Charlie.
And everything else.
And my friends, they offered 1 little point for that. So this is a 1-pointer. Not too bad. Part C I'm going to come back to in just a little bit. It's dinner time. All right, here we go. Time to land the plane. I need to find the value of the integral from 0 to infinity of x times f of x with respect to x. And they've told me, because the College Board has decided to be kind, that the integral from 0 to infinity of e to the negative x squared with respect to x is the square root of pi over 2. Now I still have all of this work to do over here, and it's gonna take some work on our part. So first thing I notice is that this is an improper integral. Why improper? Because you are evaluating at infinity. You're trying to find the integral of x times f of x from 0 to infinity. You have an improper integral, and the College Board is very, very particular in the way that you're going to do this. you cannot work with an improper integral. Instead, what you do is you turn it into a proper integral by doing something like integrate from 0 to b x times f of x with respect to x, and then take the limit as b approaches infinity. And sometimes just doing that will get you a point. Sadly, that's not the case here. But this is now a proper definite integral. So we get to work with this in all sorts of nice, clever, creative ways. And what I'm going to do for right now, I'm going to ignore the limit as b approaches infinity. I'm going to ignore the 0 and the b, and I'm just going to think about how could I possibly integrate x times f of x with respect to x. Well, let's see. Substitution, probably not. I'd be looking for a baby and the derivative of the baby, and I don't have that. But I do have two things being multiplied together. What this makes me think about is integration by parts. Told you, this is a advanced integration problem. We've got an improper integral. Right now we're focusing on the indefinite integral. My recommendation is that we do integration by parts. If you need a little hint for the formula is the integral of u dv equals uv minus the integral of v du. When you're working with integration by parts, you select part of your integrand to be the u, part of the integrand to be the dv. Generally speaking, you want the u to be the part that will become simpler when you take derivatives, but the dv has to be something that you know how to integrate. Well, if u is the x, then dv has to be f of x dx. You then go and you find du. Well, if u is x, then du is just 1 dx. To find v is the integral of f of x with respect to x. And you might start to think, well, what the heck am I going to do with this? Remember, you actually just did this work in part B. We showed, because f of x is really x e to the negative x squared, we know that this integral in part B we showed is negative 1/2 e to the negative x squared. So using integration by parts, what I have now is u times v, so x times negative 1/2 e to the negative x squared, minus the integral of v, negative 1/2 e to the negative x squared, times du, that's 1 dx. This is what I'm trying to integrate. Well, I can write this as negative 1/2 x e to the negative x squared. That negative 1/2 is a constant. I can pull it out front. This becomes positive 1/2 integral of e to the negative x squared dx. And all of this is equal to my original indefinite integral x times f of x with respect to x. Now, unfortunately I wrote it on the wrong side, but everything's fine. Everything's mathematically valid. Here's the tricky part. What you need to do, though, is not just find the antiderivative, although that part was really good. You need to evaluate the limit as b approaches infinity of the integral of x times f of x with respect to x. We know that all of this equals this stuff up here. So we've got now the limit as b approaches infinity, negative 1/2 x e to the negative x squared, plus 1/2 the integral e to the negative x squared with respect to x. And we're going to evaluate from, my lower limit was 0, and my upper limit is b. Lower limit 0, upper limit b. To do this, we're going to plug in the b. You're going to plug in the 0, and you're going to subtract. So we get the limit as b approaches infinity of negative 1/2 b e to the negative b squared minus a negative 1/2 times 0, e to the 0. What I'm doing is evaluating this first part from b to 0, plus 1/2 my integral of e to the negative x squared with respect to x from 0 to b. You're taking the limit as b approaches infinity of this whole expression. Holy Toledo. Well, e to the 0 is 1 times 0 is 0, so good news. All that's 0. I need to find the limit as b approaches infinity of negative 1/2 b e to the negative b squared, plus I have to find the limit as b approaches infinity of 1/2 the integral from 0 to b e to the negative x squared dx. Now, we still have a lot of work to do here. I know I'm coming up on the bottom of my page, and you guys are probably like, what on earth am I supposed to do? You're just supposed to keep going and do the best that you can. Okay? So, here's the thing. This limit as b approaches infinity of 1/2 the integral from 0 to b, I'm going to rewrite this as 1/2 the limit as b approaches infinity from 0 to b e to the negative x squared dx. Well, what is this? This part right here is simply the way that you write the integral from 0 to infinity of e to the negative x squared. Remember, we're still multiplying by 1/2, and you were told in the beginning of the problem that the integral from 0 to infinity of e to the negative x squared is square root of pi over 2. So this part is equal to 1/2 times the square root of pi over 2. Now I want to be careful, and I want to get rid of this equal sign here. That's just this part of the integral. I still have to go and evaluate, so I'm going to add on to this, the limit that I get over here. And this looks crazy to me. But what if I was clever and I rewrote this as negative 1/2 b divided by e to the b squared. Because I had e to the negative b squared, rewriting it this way is okay. What's the limit as b approaches infinity now? Well, the negative 1/2 is a constant. That's not going to change. You have b in the numerator. You have e to the b squared in the denominator. B is approaching infinity. What happens here? You have an exponential in the bottom. You have a linear expression in the numerator, exponential in the denominator. Which one grows faster? Well, the exponential grows faster, which means that this whole limit is 0, and your final answer is going to be 0 plus 1/2 the square root of pi over 2, so you're going to get the square root of pi over 4. That is it. And you want to know the really, I think, frustrating part here? I mean, not only was A way crazy, part B, not too bad. In part C, they awarded 2 points for reaching this part here. When you applied integration by parts, you got 2 points. All this work down here that you had to do with the limits and thinking about relative growth rates or L'Hopital, that's worth 1 little point. Of course, if they had told you it was worth 1 little point, I bet you wouldn't even bother trying all of this. I have done this problem 3 different times, and I have gotten myself tripped up just about every single time. It is a really tough question. Don't let this shake your confidence. If you come across a question like this on Tuesday when you take the AP exam, do the best you can with the time that you have and move on. Move on. All right. All my best to you all. Bye.